Hello geometers, this is Miss Backfish, and I had just finished making a video of notes on inscribed angles and decided I would go ahead and make you another one that is just a bunch of practice problems for you to try on your own, work through, or if you're in my class right now, I have probably assigned them to you. So here we go. First thing I want to do real quick is review the basics of inscribed angles. First, we have to talk about what an inscribed angle is. It is an angle that has sides that are chords in a circle and the vertexes on the circle. The arc that is between the two sides of the angle, if you consider the angle, like trace it out the way I have to show it going beyond the circle, the part that is cut off between the two sides of the angle is called the intercepted arc. There are four important facts or theorems about inscribed angles. This is the first one and the most important one because all of the others come out of this. The measure of an inscribed angle is half the measure of the intercepted arc. So for instance here, the angle is 37 degrees. That's half of 74 degrees, which is the intercepted arc. Next, if two inscribed angles intercept the same arc, they're congruent. So here we have two different angles that both intercept arc QT. So whatever arc QT measures, each of those is going to be half of it. So they have to be the same as one another. Our third theorem says if an inscribed angle intercepts, excuse the bell here, sorry. If an keep ringing. There we go. If an inscribed angle intercepts a semicircle, it's a right angle. So here we have this angle QPM or MPQ. It is intercepting between the two sides is a whole half of the circle or an entire half of the circle. So that's 180 degrees, and therefore that makes our inscribed angle 90 degrees. Another way of looking at this is if you have a triangle that is inscribed in a circle, meaning all 3 points are on the circle, and one side of the triangle is a diameter, then that's automatically a right triangle. And our final theorem about inscribed angles is that if you have 4 points and connect them, making a quadrilateral, where all 4 points are on your circle, then opposite angles will automatically be supplementary. So A plus C adds up to 180, and B plus D adds up to 180. And that's the only way you can have a quadrilateral fit in a circle. A quadrilateral can be inscribed in a circle if and only if the opposite angles have to be supplementary, or else it wouldn't work. It wouldn't fit in the circle so that all 4 points were on the circle itself. Okay, so let's go ahead and do our practice problems here, get into those. Here's how this is going to work. I'm going to show you a problem, give you a second to hit pause if you want to, and go ahead and try the problem yourself. And then I'll go ahead and explain the problem. So we got 10 problems, starting with this one. All right, the question mark indicates that what we're looking for here is the measure of arc LM. Go ahead and hit pause to give it a chance, give yourself a chance to try it. Okay, so here it is on my paper. The first thing I would notice here is that LM is the intercepted arc for this angle, whose two sides meet at N. So if I knew this angle, then I would know that arc because this angle is going to be half of that arc. Another way we could look at it, we could either go about finding that angle first, or perhaps maybe even easier on this one, we could say that arc plus this arc MN, has to add up to 180. So if I could find arc MN, I could subtract it from 180 and know what the missing arc is. I can find the measure of arc MN because here's my inscribed angle for MN. It's the 53 that we were given. So if the inscribed angle is 53, that's the half. Angle is half of the arc. If the inscribed angle is 53, the arc has to be 106. And then I can go ahead and subtract that 106, and grab my calculator, from 180 to find out my missing arc measure. How do I know they add up to 180? Because everything on one side of a diameter always adds up to 180. A diameter cuts the circle into 2 halves. So because of this point in the middle, that's indicating to me that LN does go through the center of the circle, so it's a diameter. So 180 minus 106 gives me 74 degrees for my missing arc, and I will go ahead and write that in. Now, another way you could have solved this one, another thing you need to be aware of this one, is that this is a perfect example of that theorem that we just talked about a second ago. In other words, I have a triangle here inscribed in a circle, and one side of it is a diameter. This right here has to be a right angle. So if that's a right angle, the two acute angles in every right triangle have to add up to 90. So this is 53. This would be 90 minus 53. And then once I get that value, which I think would be 37, I can double it to get that angle. So that's another way to approach this one. Next up, go ahead and hit pause. Give yourself a chance to try this problem. We're being asked for the measure of angle FEW. Phew. Measure of angle FEW. And notice EW does not go through the center of the circle. DF does, but not EW. Okay, so my first instinct, anytime I see that I'm looking for a missing angle or a missing arc, is to figure out which of the other it goes with. In other words, if I'm given the arc, which angle does it go with? If I'm given the angle, which arc does it go with? So I'm being asked for this angle, which means I need to know either that, or I could find it by knowing if I knew arc FW's measure, because this would be this angle, the question mark, is half of this arc. Well, I do have a diameter here. I have the diameter DF. And remember, every diameter, I'm going to go ahead and keep going with it, chops the circle into 2 halves, and each half is 180. So if I know that this part right here is 92, I can subtract from 180 to find the measure of arc FW. So I can do 180 minus 92. That gives me 88 degrees. So this part right here, this arc is 88 degrees, which means that the angle we're looking for would be half of 88 degrees. So that angle is 44 degrees. 88 divided by 2. I really like that color. Next, we have number 3. We are given the measure of angle RTK. Okay, that 49 degrees goes right there up close to T. RTK is 49 degrees, and we're being asked for the measure of arc TK. Hit pause and try it. Okay, this time, when I look at what angle does this particular arc go with, that gives me this angle over here, angle TSK or KST. And I don't necessarily think that's what's going to help me most, because I'm noticing that this the one that was given to me as 49 intercepts this arc. So if that's 49, this has got to be 98 degrees. And once again, I have a half circle down here. Everything on one side of RT has to add up to 180. So I can just subtract 98 from 180, and I will know the measure of my missing arc. Sorry for the auto-focusing going nuts there. And that's 82 degrees. Now I could find the measure of angle TSK or KST if I wanted to. This would be 41. But there wasn't really an easy way to find that earlier. Number 4. I'm not going to say anything about this one. I'll just let you try it. Hit pause if you need to. Okay, now a lot of these, just keep in mind, a lot of these you might see something differently than I see it in terms of what you want to look at first. And that's okay. But keep in mind that some things that we look at first, okay, this doesn't help me. What else do I see? We have to move on. My first thing I see here is that I have a quadrilateral. It's 4-sided, and it's in a circle, which means that opposite angles, F and D, or V and E, but opposite angles have to add up to 180. They have to be supplementary. The reason I mentioned F and D is because I don't really know angle V or angle E, but I do know angle D. So since this is 96, I can say 180 minus 96 and know that this angle is 84. Okay, well, let's see how that helps me. That angle is 84. Let's trace it just to see where that angle goes. Here's one side. Here's the other side. Well, the intercepted arc for that angle is all of this part right here, all the way across here. We know part of that is 78, and the other part of that is the part we're trying to find. So if I can figure out what this entire arc is, all the way across, then I could subtract the 78 and know what this missing arc is. And I can. The inscribed angle is 84. That means the arc has got to be twice as big as that because the angle is half the arc. So 84 times 2 gives me 168. That means this big arc all the way is 168. And this part right here is 78. So if I subtract 168 minus 78, I will know what this part, arc DE, is. And arc DE is 90 degrees. Number 5. What should I see as soon as I look at that picture? What should I notice about it? Go ahead and pause and try it. Okay, I'm going to switch up my colors a little bit, get a little tired of those. The first thing I should notice when I look at this is that they have shown me a diameter. ZY is a diameter. We can always use a diameter because it cuts the circle into 2 equal halves, so everything on one side of it has to be 180. Okay, so let's look at this angle. The angle that we're being asked for, here are the 2 sides of it. So that means the intercepted arc is arc XY or YX, either way you want to put it. All right. And then if everything on one side of a diameter, here's my diameter, here's my pencil. Everything on the right side of that has to add up to 180. Everything on one side of that diameter has to add up to 180. So that's everything over here. So I already know that part of it is 108. That's from Z to X. So if I know that altogether it has to add up to 180, I'm just going to say 180 minus 108. And the green part will be 72 degrees. Now, that's not what I was asked for, is it? But it allows me to find what I was asked for because I was asked for the angle that intercepts that arc. So my inscribed angle that has an intercepted arc of 72, the angle is going to be half the arc. So this will be 36 degrees because that's half of 72, or 72 degrees divided by 2. Number 6. See what you can do. Okay, the interesting thing about this one, when it comes to that whole strategy of let's see which arc goes with which angle or which angle goes with which arc, if we're only looking at this arc, arc AB, there's not really an angle that intercepts just that portion because there's not a ray or a side of an angle that goes through this side. Well, there is one side, but the other doesn't go through here. There's not an angle where both sides go through A and B. So instead, let's look at the information we were given. We were given this 74-degree angle, among other things. And I'm going to go ahead and look at what angle that is. That has one side over here and one side over here. All right, well, so my question mark right there is in the intercepted arc for that angle. So this is a little bit like number 4 we just did a little while ago. If I know that this is 74, then the entire arc all the way across from one side to the other has to be 2 times 74. 2 times 74 is 148. Okay, so if I know this entire arc that goes from A to C through B is 148, then I can subtract this portion that I know is 82, and that will tell me what's left over and what the measure of the arc AB is. So 148 minus 82 gives me 66. And that's the measure of this arc right here. On number 7, you notice there's not a diameter, so you can't use anything with, 180 minus such and such. That's not really going to help you when you don't have a diameter. But remember, you still do know that an entire circle adds up to 360, so that might be something you could use. Go ahead and hit pause and work on it. Okay, here we go. I'm going back to some old colors here. This angle, this inscribed angle, that measures 39 degrees, that we're told that, angle XWY, or you could call it YWX, it intercepts the arc that goes between X and Y. So that means if I already know that this is 39 degrees, then I'll be able to find this arc. And then you notice we'll have all the whole rest of the circle except the part we're being asked to find. And remember, the entire circle has to add up to 360 degrees. So let's go ahead and find this arc right here. 39 is the angle, it's half the arc, so 39 times 2 tells me my arc is 78 degrees. And now I know that from W all the way around to Y through X, in other words, major arc WXY, is going to be 150 plus 78. So that's 228. So that's basically, you don't have to write this on there, but just to show you what I'm talking about. This blue part, all the way around like that, that's 228. And that's the whole circle except for the part we need. So we're going to subtract 228 from 360, and that'll give us the part we need. 132 is my missing arc. And I will write that right here. Here's number 8. Go ahead and give it a try. And here's what it looks like on my paper. Remember, we've got a theorem that specifically says if you have a quadrilateral in a circle, then it's going to have opposite angles that add up to 180. The opposite angles have to be supplementary. The quadrilateral can be inscribed in a circle if and only if opposite angles are supplementary. So that's what I'm going to use here. Because if I can figure out angle E, then I will know this intercepted arc. Let's go ahead and do that. Now, if you're wondering on some of these, how does she know she needs to find this in order to find that, etc.? How did she know to find this first? If you don't, first of all, it's something of an instinct. You start to see these. The more of them you've done, you start to be like, oh, okay, I see that this angle goes with that arc, that kind of thing. But it really doesn't matter. If you try to find something else first, if you're like, well, okay, I see that this angle goes with that arc, and then you do that and you're like, oh, that doesn't help me, then that's fine. Now go find something else. See what you can find. Use the information that you're shown and see where it takes you. Because I know that opposite angles in a quadrilateral are supplementary, I know that 180 minus 102 will tell me this angle over here. Okay, so 180 is 102 plus what? That's a 78. So angle E is 78 degrees. And then notice I traced the sides of that 78 degree angle so that I could show that it intercepts this portion of the circle. If it intercepts that portion of the circle, then that portion of the circle has to be twice as big as 78. So I can do 78 times 2. 78 times 2 is what, 156? So this whole part all the way across has to be 156. And this whole part 156 is the question mark plus 60. In other words, the missing arc DC, plus 60 gives me 156. So I'm going to subtract the 60 from the 156, and I'll have my answer. 156 minus 60 gives me 96 degrees, And so this is 96 degrees. Please forgive the bell again. Next to last problem. We're closing in on the end here. Another quadrilateral in a circle. Pause if you need to. Okay, so here we go. This one has a little bit, this is going to be a few more steps than some of the last ones. So this is a perfect example of if I don't know where the answer is going to come from, let's just see what I can find out. Let's just see what I can figure out so far. Well, first of all, there's nothing you can say is half a 62 because there's not an angle, a single angle, where the two sides of the same angle that meet at the same vertex go through P and Q. So you're not going to have 31 for any angles, okay? Now we have a quadrilateral in a circle, so that means that our opposite angles have to be supplementary. So I can say angle R is 180 minus 74 because R and P are opposite angles. So that's 106. And I could do the same thing with Q and F because Q and F are opposite angles. So 180 minus 85, that gives me 95. So angle R is 106 and angle Q is 95. Probably should have used a thinner pen there. Those are kind of crammed in there. This is 106. That's a 6 and a degree symbol. 106, 95. Now, I still don't have anything that jumps out at me as obvious in terms of how to find this arc right up there. All right, but what does occur to me is that if I knew this arc RQ, I know that this entire intercepted arc, all of that has to be twice 74. 74 times 2. 74 times 2 is, what is that? 148. So all the way across between these two sides is 148. So if I knew what this part was, I could subtract it like I've done on so many other problems, and I would know my question mark. I would know the measure of arc FR. But I don't know what the measure of RQ is. So I'm going to have to use something else to find out what the measure of RQ is. So that's why I say this is like a couple of steps. Okay, so at the risk, I don't want to draw too much on one figure. So let's just go ahead and turn our attention to angle F, the one that's marked 85 degrees. Which arc on the circle, what part of the circle does angle F intercept? And when we do that as a separate picture, this is what we see. It intercepts all the way from R to Q and also to the 62 degree arc down here. This is going to be my way that I can find RQ because 85 has to be half of this entire arc all the way around. 85 times 2, I was trying to show you and I typed a bunch of wrong buttons. 85 times 2 is 170. So this whole big arc is 170. And that means if I take the 62 degree part out, I will know what the measure of arc RQ is, and then I can use it back over here. So 170 minus 62 gives me 108. So the measure of arc RQ is 108. And I can say this part right here is 108. And remember, we already knew from F to Q is 148. So if F over to Q is 148 and this part of that is 108, I can subtract and I'll know how far it is in degrees from F to R. And so I'm going to do 148 minus 108 and I get 40 degrees. So the measure of arc FR is 40 degrees right here. Last problem. I do see a diameter, so that's helpful. Don't see a quadrilateral. I do see some triangles inscribed in circles, so those might help me. Pause it and give it a try. Okay, so the first thing I see here is the only thing I'm really given is this angle that's measuring 30 degrees. That's the angle right up there, C. So RCQ measures 30 degrees. Okay, well that tells me that the arc it intercepts measures 60 degrees. But that's not the only angle that intercepts that same arc. I have another angle over here that intercepts the same arc. I'm actually going to go ahead and trace it in orange also. It's the angle with vertex P. One side goes through R, one side goes through Q. So it intercepts that same arc RQ. And remember, two angles that intercept the same arc will be the same size. Not only was that a theorem, but we also just kind of showed it, because if they are both half of a 60-degree angle, they have to be the same. Okay, so now I think the easiest path to the final answer, and I'm going to use a different piece of paper here now, is to look at that right triangle. What am I talking about? Well, let's see if I can put them both on here. Whenever you have a triangle, 3 points that are on the circle, and one side of the triangle is a diameter. So this triangle right here is what I'm talking about. It has to be a right triangle. It's the same as saying that it's intercepting angle Q, the big angle Q here is intercepting a semicircle, so it's 90. So this is a right angle right here. Every time we have a right triangle, we have one angle that's 90, and then the other two angles have to add up to 90. This one's actually a special right triangle. If I know I have 90 and then this is 30, this is going to have to be 60. So that's my measure. That's the answer. This is actually a 30, 60, 90 triangle. And that gets us to the end. Hope these have been helpful for you. Let me know, and I'll see you next time.